This is ZB, ZB and ZA, and this is ZA. Okay, our motto: determine Z parameter corresponding to the circuit. Okay, this is the lattice network. Okay, that is lattice network. Agar if this type of arrangement so, then that is the lattice network. Okay, so first of all we have developed formula. Okay, it is very clear. If ZA like this one and this one same, and this one and this one is same, then an arrangement like this one, then that is called lattice network. And how to develop the formula, and after how to can resolve the circuit. Okay, so first of all I know that this is the port 1 and this is the port 2. Current I1, voltage V1, and here current I2 and here I2, and voltage corresponding to V2. Clear? Okay, very simple. Now, so first of all, this one is 1 dash, that is 2, and that is 2 dash. If you make 1 dash, clear? First of all, redesign the circuit again. Now, and that is 2 and 2 dash, that is 2 and 2 dash. Clear? Now, 1 connected to 2 dash, 1 connected to 2 dash. So make like this one, that is ZA. Clear? 1 connected to 2 dash, 1 connected to 2, 1 connected to 2. So it is make like this one. Very simple. That is ZB. Okay. Now another way. 1 dash connected to 2, 1 dash, this is 1 dash connected to 2. It means this one connect like this. What about 1 dash connected to 2 dash? Sorry, 1 dash connected to 2, 1 dash connected to 2, that is ZA. And now last one, 1 dash connected to 2 dash, and this is ZB, that is ZB. Very clear? Okay, very simple. 1 connected to 2, ZB, 1 connected to 2 dash, that is ZA. So this one V1, and this one plus minus, so plus minus, that is V2, and current I2, and here I1, here I1. Okay, now if current Ix here, then I1 minus Ix. Okay, now current in this branch, that is I1 minus Ix minus I2. Okay, and here I2 plus Ix. Very simple. Okay, apply KVL. Clear? Now apply KVL in this loop. We got minus V1 plus ZB into Ix plus ZA into I2 plus Ix. This is equal to 0. So V1 is written as ZA plus ZB into Ix plus ZA into I2. Clear or not? Very simple. This is the equation number 1. Now apply KVL. Apply KVL in here loop 1. Apply KVL in loop 2. Minus 2 plus. So first of all, minus 2 plus minus V2, that is minus V2. Minus 2 plus minus ZB into Ix plus ZA into I1 minus Ix. This is equal to 0. So V2 this is equal to, it is written as ZA into I1 plus ZA plus ZB into Ix. That is equation number 2. Clear or not? Very simple. V2 this is equal to minus 2 plus and plus 2 minus. So finally we got ZA into I1, and if V2 is going on other side, then it is minus. Very simple. Okay, now Apply loop analysis corresponding to super loop. Apply KVL on this loop. So minus 2 plus minus ZA I2 plus IX, very simple, minus ZB into IX plus I1 minus IX into ZA plus ZB I1 minus IX minus I2. This is equal to 0. Now minus ZA I2 minus ZA IX minus ZB IX plus ZA I1 minus ZA IX plus ZB I1 minus ZB IX minus ZB I2, this will be equal to 0. Okay. So first of all IX and IX. Okay. Minus 2 times ZA plus ZB into IX. Okay. After that, what about I1? I1 here, I1 here. Okay. So plus ZA 2 times ZA 2 times ZA into I1. Now next one, sorry, silly mistake. I1 is common, ZA plus ZB. I1 is common, ZA plus ZB. Next, same minus I2 ZA plus ZB, this is equal to 0. Okay. If ZA plus ZB ZA plus ZB common in both, in all, then we got finally IX, this is equal to I1 minus I2 by 2. Very simple. If this value put in equation number 1 and 2, and we got corresponding to Z parameters. Okay. So first of all make it. Now what about V1? V1 is ZA plus ZB into IX, that is I1 minus I2 divided by 2 plus ZA into I2. Okay. So if you take ZA plus ZB by 2 into I1, and we got ZA minus ZB divided by 2 into I2. Very simple, that is V1. Okay. Now if this value put in equation number 2, then we got V2, this equal to V2, this equal to ZA I1 minus ZA plus ZB into I1 minus I2 divided by 2. Now ZA I1, that is 2 times of ZA I1, okay, minus ZA minus ZB, sorry, into I by 2, and minus ZA plus ZB by, okay, sorry, this is I1. So we got ZA minus, sorry, this is plus ZA minus ZB divided by 2 into I1 plus ZA plus ZB divided by 2 into I2, that is V2. So finally we got What about Z parameter? That is Z parameter is half in half and corresponding to half, that's why half is common. We got ZA plus ZB, and here ZA minus ZB, and here ZA minus ZB, and that is ZA plus ZB. Very simple. So if impedance given ZA means both impedance are same and this one and this one same, then we got the formula corresponding to this one. If you got the value of something, then we put and find the answer finally. If value are different, then how can resolve? I have also discussed next question. So first of all, make it. Now put the value. ZA is J2 and ZB is 2 ohm. So ZA plus ZB, that is 2 times 1 plus J, and ZA minus ZB, that is 2 times 1 minus J, sorry 2 times J minus 1. So if you put this value, and 2 is common in all, that's why finally you can return as 1 plus J, J minus 1, J minus 1 and 1 plus J. This is the final answer corresponding to given question. Okay, first of all make it. After that we have discussed another question. So it is clear how can resolve it, because if this type of problem asking, if both are same and graphically representation like this one, then we got the formula, direct formula used and got the answer. But in case of different thing, if impedance are different, suppose that is 4 ohm, this one is 4 ohm, that is 2 ohm, and that is 8 ohm, and that is 6 ohm. Okay, then how can resolve it and determine Z parameter, Y parameter, and whatever be the, okay, our motto determine, suppose that Z and Y both, Z and Y parameter. Okay, so first of all, how can resolve it? Okay, now same thing, that is plus minus 1 1 dash, that is 1 1 dash, and here represent like this one, 1 connected to 2, that is 2 2 dash, 1 1 dash, 1 connected to 2, 1 connected to 2, that is how much, 4 ohm, and 1 connected to 2 dash, how much, that is 2 ohm. Now 1 dash connected to 2, 1 dash connected to 2, that is 8 ohm, that is 8 ohm, and 1 dash connected to 2 dash, that is 6 ohm, and this one is a 6 ohm, that is 6 ohm. Okay, now if we consider that is I1, here also I1, if this is Ix, then I1 minus Ix, if this is I2, then Ix minus Ix plus I2, and here I1 minus Ix minus I2, and that is I2 current. Okay, plus minus, plus minus, plus minus, plus minus, apply KVL, plus minus V1, and that is plus minus V2, apply KVL in loop 1, so V1 minus V1 plus 4Ix plus 8 Ix plus I2, this is equal to 0. So V1 this will be equal to 12 ix plus 8 I2. Okay. Now apply KVL in this loop. Minus 2 plus, that is equation number 1. Minus 2 plus minus V2 minus 4 ix plus 2 I1 minus ix, this will be equal to 0. So V2 this will be equal to 4 ix 2 I1 minus 6 ix, that is equation number 2. And now next target, apply KVL corresponding to whole super loop. Minus 2 plus minus 8 ix minus I2 minus 4 ix plus 2 I1 minus ix plus 6 I1 minus ix minus I2, this will be equal to 0. Now, so finally minus 8 ix minus 8 I2 minus 4 ix plus 2 I1 minus 2 ix plus 6 I1 minus 6 ix minus 6 I2, this will be equal to 0. So minus 8 minus 4 minus 2 and minus 6 minus 20 ix. Now next one, 6 plus 2, that is 8 I1, that is 8 I1, and that is 14 I2, this will be equal to 0. So ix is written as 8 I1 minus 14 I2 divided by 20. So we got 4 I1 minus 7 I2 divided by 10, or you can say that ix is written as 0.4 I1 minus 0.7 I2. Okay. Now if this value put in equation number 1, then we got 12 into 0.4 I1 minus 0.7 I2 plus 8 I2, this. Okay. Now after that 44.8 I1 and minus 0.4 I2. So V1 is clear, that is 4.8 I1 minus 0.4 I2, equation number 3. Okay. Now if this value put in equation number 2, so V2 is equal to I1 minus 6 0.4 I1 minus 0.7 I2. Okay. So we got that is 0.4 I1 and plus 4.2 I2, that is V2. So what about Z parameter? So what about Z parameter? Z parameter is 4.8 minus 0.4 and minus 0.4, and that is 4.2 ohm, that is Z parameter. Our motto determine Y parameter also, Y, G, whatever. So if two equation, then we can also convert another equation also. If you want to Y parameter, then we solve with the help of this one. Okay. Or another method, simply I know that I1 in the terms of V1, Y12, V2, and if you convert like this one, if this two equation, that is equation number 4, if these two equation convert in the terms of I1 and I2, okay, then you can also find Y parameter. Okay. So now corresponding to here I2 is, that is 4.8 I1 minus V1 divided by 0.4. Okay. So if this value put here, okay, then we got V2 this will be equal to minus 0.4 I1 plus 4.2 divided by 0.4 into 4.8 I1 minus V1. So minus 0.4 I1 plus 4.2 divided by 0.4, we got about 10 point, that is 10.5 into 4.8 into I1 minus 10.5 into V1. So that is 0.4 I1, our motto this one and this one. So 10.5 into 4.8 like this one minus 0.4, that is 50. So finally we put so finally we got I1 this equal to, that is 50 I1. If that is 50 after solving, that is minus 10.5 V1, this will equal to V2. So I1 this will equal to 10.5 divided by 50 V1 plus 1 by 50 into V2. Okay, so 10.5 divided by 50, we got 0.21 into V1 plus 0.1 divided by 50, that is 0 to V2, that is I1. Okay, that is equation number 4. Now if this value if this value put in 1 R2 R3, sorry, 3, V2 this will equal to minus 0.21 into V1 plus 0.02 V2 plus 4.2 into I2. So what about I2? I2 is first of all V2 is, it is written as 0.4 into 0.21 like this one, that is minus 0.084 V1, okay, and minus 0.008 V2 plus 4.2 I2. Okay, so 4.2 I2 it is written as plus 0.084 V1, okay, and plus 1.008 V2. If divided by 4.2 and divided by 4.2, then we got final answer is 0.084 divided by 4.2, that is 0.02 V1, okay, and 1.008 divided by 4.2, that is finally 0.24 V2. So our motto Y parameter also done. Y parameter corresponding to, that is 0.21 and that is 0.02, and here that is 0.02 and that is 0.24 ohm inverse. Okay, so finally we got corresponding this one. If any H parameter, G parameter, you can also determine, make it.